Hello everyone, welcome to today's webinar with MicaSense and SimActive. I'm Laura Gomez from MicaSense marketing team, and I'm here today with Emily Shoshalski from our sales team and Simon Grandin from SimActive team. We're going to present today customizing your multispectral processing workflow in Correlator3D. So I'm going to let Emily and Simon introduce themselves and we can start this webinar.
Great, thank you, Laura. So my name is Emily, as Laura mentioned. I'm a channel sales manager on the MicaSense team. I get to work with a lot of our great drone and software partners, including SimActive. So excited to talk about Correlator3D today, as they've recently introduced multispectral processing to their workflow. And I'll let Simon introduce himself as well.
Thank you, Emily. So my name is Simon, and I'm the photogrammetric workflow specialist here at SimActive. So basically, my role is to help SimActive customers to enhance their workflow and get the best data, the best output possible for any input data, such as MicaSense camera here at SimActive.
Great, thank you. So just a brief look at the agenda for today. I'll be starting it off with the hardware discussion, and I'll keep that pretty brief, talking about our sensor suite and then the main considerations for processing our data. And then I'll pass it over to Simon, who will introduce SimActive and go through some of the features of Correlator3D that might be especially interesting to multispectral users. And then we'll focus a lot on the live demo that Simon will be walking us through, and that will be with Ultim data. And then as we go along, feel free, if questions come up, to enter those into the sidebar, the toolbox for GoToWebinar. And Laura will be fielding those and reading those out at the end. So we're open to any questions you might have. All right, so the MicaSense sensor suite, we started off back in 2014 with the red edge sensor at the top there, and we've gone through a couple different iterations of that, landed at the MX model that we have today. We built off some of the architecture from the red edge sensor and developed the Ultim sensor next on the left there, and that has higher spatial resolution for the multispectral bands, and we've added a FLIR thermal sensor there for synchronized thermal imagery along with the multispectral. Good for looking at water stress and irrigation systems with the thermal band. And then most recently, we came out with the dual camera system. So that is, we've added a second red edge. So we have two red edge that are fixed mounted together, and then we've synchronized the capture, so you get 10 multispectral bands as an output. So really good for kind of land monitoring or land management applications, and for people that want to use, high resolution drone-based imagery and then scale that up to satellite. A good option there, since the bands correlate with Sentinel-2 and Landsat 8 satellite. And then all of our sensors come with a DLS2. That's how we're doing that's our light sensor, part of what we use for the radiometric calibration. And then that DLS2 also has a GPS embedded there to geotag all the imagery. And then the only thing not featured here is the panel that comes with all of our kits, also for calibration. So what's exciting about the Correlator3D software is that it can process all data from all of these sensors. So it can process, even the thermal band and the 10 multispectral bands. So some of the considerations for processing our multispectral data, these are the main things that we kind of go through and work with software partners like SimActive to make sure are in place to get the best, utilize the data to the best extent. So first of all, we've got between 5 to 10 different imagers. They're all in slightly different locations. So there does need to be a band registration so you can get pixel aligned outputs. Then, of course, you need to be able to stitch the imagery into an orthomosaic map. It's taking the raw imagery and it's converting it to reflectance information. And then last but not least, it's doing a radiometric calibration process. So that's utilizing both the DLS2 data and the panel capture that's taken before or after the flight. And what we also like to see with this step is some flexibility, and Simon will be discussing that. But on a cloudy day where there's fluctuations in the lighting condition, that's where the DLS2 will really shine. So being able to use both the DLS2 and the panel. Whereas on a sunny day, you really just need the panel for best results. So being able to customize a little bit what information you're using for the radiometric calibration process. So with that, I will pass it over to Simon, who will be introducing SimActive and then getting started with the demo.
All right, thank you, Emily. So yes, so Correlator3D and SimActive are a photogrammetry software since 2003. We're the first software that's GPU based for processing aerial data and satellite data, and also UAV data. We're a Montreal-based company. We have customers all around the world these days. So as I said, we can process different types of data from the UAV, the aerial, and also the satellite data. And also the main advantage of Correlator3D is basically we're known for our exceptional precision. So the high quality of data we're able to deliver with the input data. The different automation of a workflow from the one button click solution to the full integrated workflow where you can go step by step. Also, as I said, since we're a GPU based mostly software, we have an unmatched processing speed, which allows us to integrate or digest a lot amount of data in a quick manner of time. And also we have an intuitive user interface, which is takes maybe a few minutes or few 10 minutes just to familiarize with the software, where the buttons are located. And also we have different types of interface. The software can be run with a graphical user interface, but can also be run with a command line interface if you want to automate your whole workflow processing. So basically, we came out with this new version of Correlator3D in the beginning of June, which we focused on the multispectral side of the UAV processing. The main focus was the radiometric calibration of MicaSense camera, and for that we're able to digest every types of imagery from the dual camera, the red edge, and also the Altum camera. Some points that can be noted is basically the band adjustment is done prior to the processing. So at the end of the processing, the user will have a surface model, a terrain model, but the ortho mosaic will be aligned with each of the band. So it's going to give you a geotiff output depending on the number of band that you have. As I said, the workflow are customizable, and you can save them and reuse them for many types of project. They can be also scripted out and launched in command line. The user also have the possibility to generate ortho photos from the surface model or from the terrain model quickly to see the difference of both of them. We can ingest for the radiometric calibration either the DLS sensor or the panel, and also both of them depending on what you have for your type of data. And the software is a desktop solution, but can also be installed in some cloud-based options such as AWS or Azure. And also we offer the possibility of sharing result over the cloud. So you can just only send a shareable link to your customers, and they can easily see the output data that you got from your MicaSense sensor. So now I've talked a bit about Correlator3D. Let's jump into the demo of Correlator3D and how you can work with an Altum data set. This is the data set that I will use for this presentation. So I will go through the workflow from the creation of the project up to the generation of the mosaic, and also the creation of the vegetation indices. So here it goes. So as you can see here, we have an Altum data set, which is basically a six-band imagery. So we have the blue, the green, the red, the near infrared, the red edge, and also the thermal band. And all of those bands will be processed as a single imagery once the project have been created. So basically, generally, as you can see on the top of the screen, we have all the modules that are in a sequential order. So you have the two first buttons, which are basically creating and opening an existing project. Then we have what we call the one button click solution, which is basically the automated workflow. So you can create an automated workflow with all the steps that's going to go through the process, and you can also change the different options directly into the automated workflow. We also have different types of profile already created for rapid processing. Also, what we really like here at SimActive is the automated workflow can be used to generate some script. So if you want to launch all your processing from the command line, you can use the automated workflow here, and you can check in that'll generate a script, and it will basically generate an output script that can be launched within the command line. And also with the script, all the parameters can be changed, and you have the full flexibility to get the most out of your data with either one of the processing options, such as the command line or the graphical user interface. So now let's see how we can create a project from the Altum dataset. So you went on the field, you got your images, then you're back at the office, and first of all, when you're gonna create a new project, you're gonna have a window like this that's gonna appear. So depending on the license type that you have, you're gonna have different types of options. For MicaSense data, you will here need to create a UAV project. And first of all, you're gonna have the camera configuration you want to use for your project. So we can ingest many types of camera and many numbers of camera in the same project. So if you have, let's say, if you're performing a big flight that is cut into several sections, you can have multiple groups for each of those flights, which gonna give more flexibility to the aerial triangulation. Or if you have, let's say, a rig with more than one camera, you can also add those two cameras within the same rig and will be processed together. The main important aspect here when we process MicaSense dataset is we need to co-registrate the band during the aerial triangulation step. So the first step here will be to check in the box unregistered band. So by doing that, the first step of the type point extraction will be to register all the bands together based on the master band that the user will select. And then we will extract the type points between all the imagery before doing the aerial triangulation. So by checking the unregistered band, it's going to give you the possibility to add a folder that contain your images. So you can add directly a folder that contains your imagery. So as we have here, I added a small folder which has roughly 21 images, and we can see that the software was able to identify which capture was belonging to what band. So as we have here, the band number 1 is the band blue, and then the green, the red, the near infrared, the red edge, and the thermal band. And from there, the user can also select what master band he wants to use to co-register all the bands together before doing the aerial triangulation. So you can change the master band here. In this case, I can use the green band, and also you can reorder the band if you want to have a specific order for your output. this order will be used throughout all the projects. So if you change the order of your band, it's maybe a good idea to remember what is the order that you have given for your different band. So if I want to edit one band, I could just click on edit band. I could change I can change the name of the band. I could also change this index value, which means where it's going to be sitting in the final output. So once this is there, now I've selected the green band as the master band. So once I'm going to load in the exterior orientation parameters that will be read from the EXIF metadata of the imagery, we can see now that all my imagery have the same number of band. So it's going to be the green band as the master band. So they all going to have the _2 as an output name. So you can click on can add, and then you can select the projection of your output. So basically, you can, depending on where you are located, you may have a different projection system or maybe customized projection system. So here, what you can do is, by default, the software will select a classic UTM projection system, but you can also select some projection by the EPSG code. If you're in the United States and you're working into a state plane coordinates, we also have those state plane coordinates into the common system. So you can choose basically the projection that belongs to your project. If you add ground control points to your project, you can also they also need to be in the same output projection from your project that will be created. So WHS 84 meter 10 north. Once this is done, basically you will have an overview of the imagery, of the description of the imagery, so the dimension of those imagery in the projection, and from there you will be able to import or to specify the camera parameters. Since we have a large database of camera, the software will read the focal length, the calibrated focal length, and also the pixel size from the camera, and all the other parameters should be left at 0 for the calibration of the camera. And finally, the user can specify where he wants to store his project in order to create his project. So once you have gone through all those steps, you're gonna have a project that will be created, which in this case is basically, I'm gonna have a base map in the back, and all those little black arrows correspond to each of the individual imagery. So the first thing you can do is you can click on one imagery, and if you want to quickly see the imagery, you can see an overview of the imagery, and you can also view the different bands. So you can quickly specify only each of those bands individually. As you can note here, the band already have been registered, since the registration will be happening when you will do the type point extraction. You can also do quickly composite color if you want to see more information about your dataset. So you can edit the image band setup, and so you can put the near infrared in the red channel, the red in the green, and then the blue and the green in the blue, and you're quickly gonna have a composite color of your single imagery. So that's a first step. If you want to analyze the data that you have captured, you can quickly see before doing all your processing, you can quickly visualize your input imagery as it is on the screen as of now. So as I said, all the modules are in a sequential order. So we have, basically, it's divided into 3 categories. So we have the first categories, which is the aerial triangulation, which is creating a single block of imaging, finding common type points between all the imagery, and place them at the good place. Once the aerial triangulation is done, the user can extract a surface model and a terrain model from the imagery, and then can perform the radiometric calibration for the orthorectification process and the creation of seamless and color balance mosaic. So the first step here will be to do the aerial triangulation. So you can select the aerial triangulation modules. So once the module has been launched, you will have a window like this that will appear, and it's going to ask you what type of type point extraction you want to perform. So you can select between two modes, so the standard and the exhaustive. Usually you can start with a standard extraction, and if you see that some images has trouble to get tied to the whole block, you can then jump to an exhaustive extraction, but usually the standard extraction will be sufficient for your typical project. So the type point can also be reviewed once this is done by clicking on the white links here. So all the links are corresponding to the type points we found between two different images. So I can easily click on one link, and I can see here on two images what are the common features that were found for this specific project. Sometimes if you have a project with maybe low texture or the overlap was not sufficient, well, you can also add a few manual type points if you want to make sure that your block is well tied together and make sure that the aerial triangulation is a solid block. The aerial triangulation is the most important part of the processing of UAV data, and it's going to have a big impact on the rest of your workflow, such as the extraction of the DEM or the orthorectification and the mosaic process. So once the type point have been extracted, you can perform the bundle adjustment, which basically going to refine the position of each of the camera, and also will calibrate the camera parameters. So the bundle adjustment here you will have a window like this, and basically the user can select the type of adjustment you want to apply on the exterior orientation and the sensor calibration. If you have imported ground control points, you can also at this point use them to refine the absolute accuracy of your model. But usually for MicaSense sensor, we suggest to leave the EOS adjustment at unconstrained and the sensor calibration as unconstrained. And you can also apply the filtering at these steps, or you can do it in a two-step bundle. So you can do the filtering on another step. So basically, you can tell to the software to remove images that maybe is going to have a higher residual compared to the rest of the image. The rest of the imagery. Like in this case, I have one images that has a higher residual for many reasons. So I can either apply the filtering directly here, or I can filtering out, let's say, on another process like this, and it's going to remove this imagery from the output of my project and make sure that I have a clean aerial triangulation. So from there, we will generate a quality report like this that's going to give you overall accuracy assessment from your project. So from the type point analysis, if some ground control points or checkpoints are used, you're also going to have all this information here. You're going to have all the parameters that were used for the bundle adjustment. So if you're running a project and coming back maybe 1 or 2 months later and you're not sure what are the parameters that you've used, you can always go back to your quality report and all those parameters will be kept there. You're gonna have also a quick overview of the before and after the bundle adjustment, the overall adjustment that was applied to the block, and then some information about the sensor calibration and the system information that was used for the processing of the project. So once you have done the aerial triangulation and you're confident with your solution, you can then jump to the DEM extraction. So we're gonna extract a surface model from the imagery. So by default, the software is working in a raster-based approach. So our main delivery is a GeoTIFF or an ASCII grid file. So it's going to be a raster file, and the default resolution is going to be 5 times the ground sample distance of the input imagery. Depending on the quality of your data, you can maybe lower that to around three times the ground simple distance. It's going to have an impact on the processing time, but the user can specify his own resolution by changing the resolution here. And can also change the vertical accuracy depending on the processing time he needs and the accuracy that he needs for the output data. And also, optionally, there's a point cloud that can be generated from the input imagery, and this point cloud can be colorized with the multispectral band. So at the end, if you want to export a point cloud, you can have a point cloud that's going to contain three colors information. It can be RGB, it can be CIR, depending on what point cloud that you want, but you can select what band you want to use later on to colorize your point cloud. So once this is done, you're gonna have a surface model like this that will be extracted. By default, the surface model is it will be saved as a SMF2 format, which is our own proprietary format. It's lighter to store, and it's easier if you want to do some modification quickly. Also, when you're going to do some modification, all the history of the modification will be kept as an history, so you can always go back into the history of the modification you have been applied to this specific raster file. So from the surface model, the user can also extract a terrain model. So we have an algorithm that's going to try to remove all the elements that are not ground related, such as trees, buildings, cars, and all those other elements. So it's an automatic tool that will remove all the elements that I've just mentioned. The user also have a few input if he wants to add more constraint to the extraction. Let's say if you want to keep some element intact into your terrain model from your surface model, you can draw some polygon as an exclusion zone and use them during the extraction, so the software won't remove any of those areas within the exclusion zone from the digital terrain model. So as you can see, we also have an editing modules, so you can quickly create some polygons. So I can go here, I can draw a polygon like this if I only want to remove, let's say, this piece of wood, and I can remove this specific section from my digital surface model. As I was saying before, all the history has been kept here within your project. So if you want to go back, you can always go back to previous steps and bring back those modifications. So we also have other tools to edit the overall DEM or for the best output possible. So we have tools to remove elements respecting the topology. You can crop some certain area, you can flatten out some certain area. If you have maybe water surface, you can flatten out those areas. You can filter out some area based on some mean or median filter. And once everything is done, it can be exported as a GeoTIFF file. So the surface model and terrain model will be exported as a GeoTIFF file. So once you're satisfied with your terrain model and your surface model, the user can select what options he wants to use for the orthorectification. So he can use either the surface model, which is going to create what we call a true ortho. So all the parallax will be removed and all the deformation on the imagery will be corrected from the surface model. And if you use your terrain model, well, it's going to be what we call a classic ortho. So it's only going to be the terrain information that's going to be used to generate or to correct for the terrain deformation during the orthorectification process. One thing, if you want to calibrate your reflectance, is before generating the ortho photos, you can import your reflectance panel. So your reflectance panel can be imported as soon as your project is creating, but it needs to be done before doing the orthorectification. So you can do the AT, the DEM, and then import your calibration panel, or you can create your project, import your calibration panel, and then perform all your steps. At this point, it's not going to have any impact on the processing. It's only at the ortho photos creation that the DLS sensor and the calibration panel will be taking into account for the remaining of the processing. So if you want to import a calibration panel, you can have more than one panel, and a great advantage that we have is those panel can be taken account over the time. So you can have one panel at the beginning of your flight and one at the end of the flight, and so both panel will be used to correct the reflectance based on when your images was acquiring. So we're doing kind of an interpolation between times to get the best correction possible for the reflectance. So if you want to import a calibration panel, you can here in your project tree add a little panel to the reflectance. You can specify let's say an ID, and then you can add your specific images that we're acquiring for the reflectance panel. So in this case, I'm going to add the panel. Here you're going to add the albedo value of your panel, which are usually typically written on the panel. So you can type in those value, and it's going to give you something like this. So if I open a panel already created, you're going to have here all the reflectance value, and from there you will be able to specify the extent of where you want to of the location of your calibration panel. So the software will automatically define the optimal position of your calibration panel, and it will use it later on for the calibration. So once your panel has been created, you're gonna have here your panel in your project tree. So you can add as many panels as you want, so you depending on how your flight configuration is done, and they're all going to be taking into account when generating the ortho photos from your project. So once you have imported your calibration panel, and you jump to the OrthoRectification module, you can go into here to the OrthoRectification, and at this point, based on the model that you've used, either the surface model or the terrain model, so if you selected the surface model and checked here the DSM base, it's going to generate a true ortho. Or if you select here the terrain model, as we have here, and then generate an ortho photo from it, it's going to do some classic ortho. So once generating the OrthoRectification, you can either select what option you want to use for the reflectance calculation, either the calibration panel, the sun sensor, or both. So you can, if you only want to use the DLS sensor, you can check out the calibration panel. If you only want to use calibration panel, you can check out the sun sensor. And once this is done, it's going to create individual geotiff imagery that is going to have the reflectance corrected. So you will be able to find into your ortho folder. So if I'm showing to here, you're going to have for each individual imagery, you're going to have an output geotiff file that's going to contain 6 registered band with the reflectance corrected. So once this is done, you can then use you can load in all the individual ortho. So as we can see quickly here, all the orthos will be selected from my project tree. So here at these steps, if you're processing a large project and you only want to see the details on a quick section, you can disable directly some specific ortho. So if you want to process maybe only one line of ortho, you can maybe select 90% of your ortho like this here, and you can disable them from the processing. It doesn't mean that the imagery are taken out of the project. It just means that they're not taking in account for this specific processing. But at any time, if you want to regenerate the mosaic for the full the full project, you can re-able back those imagery within the project and generate the output for the full project. It's the same thing with the DSM and the DEM generation, but you can also disable imagery directly. You can disable complete flight lines, or also you can disable some specific images, as we have here. All those imagery were disabled of the processing, so those this low triangles was not used for this processing. This really gives the full flexibility to the user on how he wants to process his data, so he can create his big project and then only process subsection quickly to see to refine his parameters, or just to define his own workflow before processing all his big project, so it can save time overall on his workflow. So once the ortho have been generated, you can generate a mosaic creation. So we're gonna create a reflectance mosaic from the input ortho that will be color balanced. You can also specify some area if let's say if you're flying with some water bodies which can have maybe different visual aspect depending on from where you're looking at. You can draw some polygons over those waters area and not use them for the color balancing. And also we usually suggest for UAV customers to check the nadir optimization. So what we will do is we will take the most nadir part of the imagery in order to generate the mosaic. So we will remove as much as possible the parallax from the input from the output mosaic. So once this is done, the user can also edit the seamline. So we have a module of seamline editing. So you can manually edit your seamline in order to have the best output possible. And from the mosaic creation module, so you can load your mosaic block like this. You can select it and then select the seamline editing modules. So the software will read all the individual imagery and will allow you to edit the specific seamline to get the best data possible. It's not mandatory to edit your mosaic, but if you really want to deliver high-end product to your customers, you can select individual seamlines like this and edit. Let's say if I'm moving to this section, so you can here select this seamline like this, and you can edit the vertices of this mosaic like this, and then save those changes to the final mosaic. And you can also edit the feathering size, so the amount of pixel that we'll use to feather the transition between two ortho for individual seamline as well. The seamline can also be exported once the output, once the edition has been done. So it can be output as a shapefile. And also, once you have done your mosaic and you have edited all your outputs, the user can also export some vegetation indices. So if you want to export your mosaic, so you can go here into Mosaic Export, and you're gonna have a window like this that's gonna open, and you have different choices for mosaic output. So you can either export a standard mosaic, which will not be included reflectance, real reflectance value. If you want to export a reflectance map, you can select the reflectance option, and we're gonna generate, let's say here, it's gonna be a 32-bit float with 6-band GeoTIFF file. So you're gonna have directly the reflectance value of each pixels with all the bends that are co-registered. So this is another main advantage. So all the information is kept into the same file. So it's easy to gather around if you want to share data with other customers. Also, if you want to export some vegetation indices, you can go into index, and also you can specify your own vegetation indices. So we already have a wide range of indices that are pre-calculated, but you can also specify your own custom index. So you can, if you want, let's say, only to maybe add two bends together. So I can have here example A plus B, and I can input what bend correspond to the A variable and what bend correspond to the B variable. So you can really customize your own index easily here within, depending on the bend you want to output. If you want to output your typical NDVI, you can go here, select the NDVI, change the order of the, take the good band here, so the red will be the band number 3, and use the floating option. So we're gonna export. It's gonna be a 32-bit float that's gonna contain your NDVI value as a raster. So and all those output will be exported as GeoTIFF file. Also, there's other options for the mosaic creation. So the user can specify the crop area if you only want to export a small part of the data. So you can import a shapefile. You can also use a shapefile if you want to tile your final output. So if you're processing a large data set and you don't want to export one big single file mosaic, you can tile it based on the shapefile to manage more easily your data. Or you can use the automated tiling option. So you can specify the fixed tile in pixel, and all the tiles that will be exported will have the same size. Or you can use the simple single tile option to export one big file for your output mosaic. Finally, the last option that the user have is to generate a 3D model. So we can generate a mesh from the digital surface model and texturize this mesh with the input images. And also, the user can specify what bend he wants to use to texturize his mesh. So he can use maybe an OBJ or a 3D model as an RGB or a 3D model as a CIR. So all the options are customizable depending on your delivery. So again, if the user wants to process the data within the graphical user interface, it can be done easily on a desktop computer, or the user can also run a script directly from the graphical user interface. So you can create your script and then run it directly within the graphical user interface, or can also call Correlator3D within command line to run this script. Finally, depending on the output that has been on your project tree, you can also share the results. So you can select what output you want to share, and it's gonna create you. You're gonna have to create a cesium link, but it's at the end it's gonna give you a URL link that you can send to your customers, and all they have to do is open this link, and they will be able to see the output data that was generated from a MicaSense sensor. So I think this covers probably a good overview of Correlator3D. So yeah. Again, we also have different types of processing options or processing flexibility. So we have node lock license. We also have a floating license. So if you want to install your license on a single PC, as we have here. We also have different flexible pricing. So we have the monthly subscription, the yearly subscription, or also the permanent subscription. We also have different types of sensors available. So UAV, which covers imagery from 50 megapixel and below, and also medium satellite or full format. So again, we can process small data sets for marketing purposes. So if you want to have a free processing, you can contact us at sell@simactive.com, and you can also download a free trial of Correlator3D on our website, simactive.com.
Thank you, Simon. So I think we still have some time to answer some questions. So I'm going to start with some that I have here. So first question, have you had any experience using the sensor and Correlator3D in the geology area, specifically regarding lake lithology?
Processing wise, we're able to process, as I said, many types of outputs. Our goal is to output all the information, such as the mosaic, the DM. But if you can find some application from geology, Correlator3D can be suited to process your MicaSense data set, and then you can analyze your data based on different spectral band, I guess. So yeah. We have some customers that are using MicaSense for geology or for various of application.
Okay, Emily, do you want to add something on that?
No, I don't have a specific example to share for geology specifically. I think the only one slightly related would be some archaeology applications that we've seen, but nothing for the application that was being questioned about.
Okay, thank you. So next question, can it handle hyperspectral sensor data? That's for Simon.
Well, Correlator3D as of now can handle up to 32 bands per images. So depending on the hyperspectral data that you have, as of now we can ingest 32 bands of 32 bits per capture.
Cool. Okay, next question. Is there a limit on the number of spectral bands that can be merged in Correlator3D?
I guess the question is related to the latest one. So if you input an images that's gonna have 32 band, you're gonna have an output with 32 band. So the number of band that's inputted will be the same number of band that's gonna be outputted.
Cool. One more. Can you remove images? Images or type points from the end of the lines that are not in the block? I think that's related to the demo.
Yes. So basically, what we can do is you can either filter images from based on their residual, but if you want to remove images from the rest of the processing, you just have to disable them in your project tree for the rest of your processing, and they won't be taken in account for your project tree. So you can, the only thing is all the image that are inputted for the arrow triangulation will be used. So sometimes if you're not doing any cleaning before starting the processing, it can have an impact. But for the DSM, the ortho, and the mosaic creation, some images can be disabled.
Cool. Thank you, Simon. One more. Does it have the stereo editing options?
So the options that we have is it's not a typical stereo typical stereo capacity, but the user can also edit the GCPs or the tie points. So it's based on a predictive approach. So as soon as you're marking maybe 1 or 2 ground control points, the software will refine will predict the position of these ground control points on the other imagery. So it's kind of a different approach, but works as better or even as good as the stereo the typical stereo compilation approach.
Cool. So there's another one. The reflectance panel imagery can also be addressed by the script processing mode.
Yes, as long as the yes, it can be it can be done by the script. It's I would say it's not it's more applied to more advanced user, but it can be used as the with the script mode as long as the right format is done.
Cool. There's another one here. Can you process images using control points?
Yes. Yes. So images can be processed with or without ground control points. So if you want to refine the overall accuracy, the absolute accuracy of the model, you can use ground control points to make sure that everything fits well within your block.
Cool. Is the software able to precisely align the bands from low altitude flights?
So basically in general, how the alignment is done, it's not based on the flight configuration itself. It's more image per image approach. So we're gonna take various imagery around the project and try to find some common alignment parameters, and we'll apply those parameters throughout the project. So it has a slight impact on the flight configuration that you have.
Cool.
And I would add to that generally, if you're using one of our sensors to 15 meters would be kind of the lowest that we'd recommend going. And we've been able to process imagery from that height and align fine.
Cool. Thank you, Emily. There's another one here. Can you say the CIR or other from single images, and can you calculate indices from single images and save them?
So yes, so the user can export either a 6-band mosaic, or you can also export only a mosaic with 3 bands. So if you're only interested into a CIR mosaic, you can export directly only the green, the red, and the near infrared band as an output. So if you only want to have 1 band mosaic, so everything is customizable with the output.
Great, thank you. Let me see if we have more questions or if we have already answered them all. Okay, can you generate and display contours from the digital surface model file in Correlator3D?
Yes. So you can either import your own contour lines, or you can select the modules, the model that you want. If you want to do it on the DSM or on the DTM, we have a tool to calculate contour lines directly in Correlator3D that will be saved into shapefile.
Great. Okay, I think there's more questions maybe. Let's answer one more. So we're still on time. 1 second. No, this is the same one. How large can the 3D mosaic size be in terms of acres?
Can you repeat the question, please?
Yes. How large can the 3D mosaic be in terms of acres?
Typically, there's no size of outputs. It's sure that if you're processing, let's say, a corridor of 50 kilometers, it can be hard to manage in a single block. We can export the mosaic, that's a full mosaic, but we suggest if it's a big output to tile it into smaller tiles, because it's going to be easier for the user just to share the data or to display the data in other solution if he wants to do further analysis.
Great, perfect. So I think with that, we can finalize this webinar today. If anyone has any further questions, you can directly contact either Emily or Simon. Their emails are on display right now on the screen. Thank you so much for being with us today in this webinar, and I really hope you'll enjoy it.
Yes, everybody, thank you for your time. Appreciate it.
Thank you very much.